I don't know if this is a bit of a homecoming, but you spent time at MIT.
That's right, yeah. I went to MIT.
Yes.
MIT has this phrase, IHTFP,
What's that?
which stands for two things. I have truly found paradise, kind of true. And also, I hate this place. Also, really felt it.
Yes.
But I'm really happy to be here.
Yes, yes. We're all happy to be here. I love that many people in the audience immediately got it because of the shared trauma that you guys have.
That's right. We're all bonded for life.
Yes. So maybe some context for people. I'm Shawn. I run an AI podcast, and I just had Kanjun on after she raised a monster $200 million round for Imbue, formerly known as General Intelligence. Maybe you'd like to introduce what Imbue is and does, and maybe we'll talk about agents.
Yeah, so Shawn asked such good questions. They were like, do you want someone to interview you? And I was like, yeah, definitely Shawn. So Imbue is an AI research company, and we work on enabling AI agents. So agents I think of agents as things, computer programs that help us accomplish bigger goals in the world. And it's kind of a spectrum. Like we go from specific agents to much more general agents over time. And I think right now we see a lot of very specific agents enabled by language models. And then also we go from kind of less autonomous agents, so like Copilot, to more autonomous agents over time. So it's kind of this like spectrum of like specific Copilots today, all the way to like general, more autonomous systems that can help us do things in the background and like plan our weddings and all of these things that we don't necessarily want to do. So that's what I think agents are.
Do you think the same system can do both?
Both the specific and the general. Yeah, so this is actually a really interesting question because there's kind of a claim out there that more specific things might be better at, the task it's for, like self-driving. Do you want a general agent driving your car, or do you want something that's like really tailored to driving your car? And I think it really depends on the use case. So what we've seen in the history of machine learning is today, we still see really specific ML models like recommender systems that are, agents, essentially. They're agentically recommending whatever they decide. And those are very specific. But we also see much more general models, and those models enable like totally new use cases, and they also do overtake specific applications in a bunch of areas. So like there were like lots of very specific NLP models a while ago, and none of those, no one uses those anymore. So it really depends on kind of what capabilities are unlocked.
Yeah, got it. And then one of the most sort of big aha moments I had from our interview was also the sort of rise and fall of reinforcement learning. Maybe you could, I think to the MIT crowd, people might think a lot about building agents with reinforcement learning, which is something that you guys were leading for a long time. Maybe could you describe your intellectual journey with Avalon, with everything that you're doing with RL and what you're doing now?
Yeah, so for everyone else's context, Imbue, it's like you imbue computers with intelligence. That's why it's called Imbue. We build foundation models optimized for reasoning, and that helps us enable agents that can actually do things in the world. Our core thesis is reasoning is one of the main things that is missing today in order for agents to actually work. I think if you try to use things like AutoGPT or whatever agents exist today, my experience, at least, is that they're extremely unreliable. And even if they're somewhat unreliable, it's still hard to use them. So in the very beginning, when we started in 2020, we'd always been interested in building general intelligence. And we started thinking from the perspective of, can we get machines to learn the kinds of things that humans learn as we kind of are born and grow up? So we're born, we have some inductive biases from evolution, so that's kind of like pre-training, but we learn things like object permanence and object continuity and the fact that gravity exists and et cetera, all of these things we learn in a relatively unsupervised way. And so we were trying to understand, can we get machine learning systems to learn these things in a fully unsupervised way? And this is in early 2020, and at that time, no one really knew the answer to that question. Pretty quickly, we discovered like the answer is yes. Holy shit! Like across video, you can in a fully unsupervised way, learn all of these things about the world: continuity, object permanence, gravity. Our agents learned to like open doors, etc. And so we explored like all of this stuff in reinforcement learning and realized like, okay, this is actually really powerful. In fact, systems can learn these things automatically. And at the same time, what we realized is they can't do any higher level things. So reinforcement learning, it's really nice for doing all this low level stuff. Like our agents learn to like climb, like hand over hand.
That's also pretty impressive.
Really impressive, yeah. Like imagine you're in VR. So the agent has a VR action space, which means it's kind of like analogous to you being in VR, climbing a wall hand over hand. And it learned that by itself. We didn't teach it. But it couldn't learn any very important things like higher level planning. So for example, if it needed to go this way or that way in order to get the food, or if it needed to, there were a bunch of puzzles in there like block stacking and things like that, and it just could not make progress on those problems at all. And so as we thought about, okay, in the real world, like what do we want to do? We want to enable these systems to like empower people and take away the kind of work that we don't want to do. What's necessary for that? Well, reasoning is necessary for that. Like breaking down tasks is necessary for that. And we kind of felt like the low-level action was basically solved. And now it was time to work on reasoning. So we mostly train language models. Eventually, they'll be multimodal and optimize them for reasoning.
Yeah, and it turned out that the LLM and NLP people had been developing a bunch of interesting reasoning benchmarks. The ones that have the best marketing, I'll say, is like the ones like HelloSwag. And what benchmarks do you think actually make sense for reasoning?
Yeah, there are not that many good reasoning benchmarks out there. And
I hesitate to say HelloSwag is good. It's comprehensive.
It's comprehensive. That's right. Yeah. So I think we think of reasoning in a slightly different way than other people. When I say the word reasoning, we might think of like being able to do math or solve competitive programming puzzles or write code and kind of like logically reason through things. And that's kind of what we mean. But really, we think of it in a much more pragmatic way. Like if I'm asking my agent to book me a flight, I want it to ask me questions when it's not sure. So like, do I prefer morning or evening flights? If it's an evening flight, if it's a red eye, would I prefer to have the window seat so I can sleep? If you don't have my TSA pre-check number, like you should ask for it. There's like all this really simple stuff for flight booking, but if you get something very complicated, like help me write a feature. We work on a lot of agents for code. Like help me write a new feature. It's like, okay, well, there are a bunch of functions in the code already. Should I refactor them in order to write this new feature? Should I write totally new functions? Like, how should I architect this? Those are all important decisions that require reasoning. And it's kind of this like higher level, it's like both being able to break down a goal into sub-goals and then figure out what the best actions are to get there, and then also being able to like zoom out and be like at a meta level, like does this strategy make any sense at all? And so we kind of think of reasoning in these like very pragmatic ways. So from a benchmark perspective, I think we kind of have an internal hypothesis that's been panning out that accomplishing goals basically breaks down into question answering. So if you have any goal, you can figure out, okay, what is the most important question to answer in order to like make progress on this goal? And you can, and then we can kind of prioritize the most important questions. So a concrete example is we did this really nice analysis of all of the Department of Commerce submissions. So the Department of Commerce asked people for AI policy submissions. And like thousands of people and tons of corporations submitted policy submissions with like 20,000 pages of text. And the Department of Commerce is like, this is sad, like we cannot go through this much text. And so we actually used our model to like go through and analyze a bunch of this text.
For the Department of Commerce?
Well, first for ourselves, because we wanted to understand what people were thinking.
Right.
And it turns out that like, this task kind of broke down into question answering. It's actually really hard to get to work well because language models tend to kind of summarize things in a really generic way. So anyway, any goal can break down into question answering. And so actually a lot of the benchmarks that we use, we build internally, and also we use kind of external question answering benchmarks. So RACE is a really good one. RACE is maybe the best kind of reasoning question answering benchmark.
Yeah, I'm not familiar with that, but I'll go look it up for sure. You mentioned code models. That is one part of the 4 or 5 things that you work on. Could you describe why code has, like it's got a special place in your thinking, and how you use code models internally?
Yeah. So let me zoom out a little bit. I think there are really 3 things that are blocking agents being built. The first one is what I call it reasoning, but it's kind of like a category of things that allow agents to do things reliably. So right now, agents, these language models, you can think of them as like a person who's read the entire internet but never done anything. They have like really strange judgment. And so the first bucket is like, how do we make these systems more reliable? And there are 2 ways of thinking about that. One is, okay, optimizing the underlying model for reasoning, it'll help it have better judgment so that it can, be more reliable. But second, I think of it in terms of error correction. So we actually had, in historical technologies, a lot of technologies that had a lot of errors. So Ethernet, for example, like packets get dropped all the time, and we invented TCP/IP. Hamming error correction exists to like error correct for bit flips. And I think we see a similar type of error correction like necessary for language models because they're always stochastic. And they will always be stochastic. No matter how good we make the reasoning, they'll always be stochastic. And so like, let's think step by step. It's actually an example of error correction. So is self-critique, et cetera. So the first bucket is kind of how do we make it more reliable? The second bucket is like tooling for developers, actually. So how do we make them easier to build? Right now, building agents feels like writing assembly code. It's not fun. They output tons of text, really hard to debug. We don't have good evals. And then the last category is, I call it kind of interface. So how do we make it easier to use agents as a user? Because it's doing stuff in the background kind of autonomously, and this is where I'll get into code, it's kind of hard to trust that it did the right thing. So
and the opposite would be ask for human confirmation at every step.
Yeah, which is really
not
annoying.
Magical.
Exactly. Yeah. So we had an early version of an agent that was doing some code, kind of writing code in the background, and we were like, oh, we can just like read the stuff it's outputting. It'll be fine. And it's like, no, this is a terrible user experience. It's, it's outputting tons of steps and iterating through them, and it forks itself and kind of like tries different strategies and comes back, and it's just like impossible for us to read through as a human. So we work on code for a few reasons. One is we really believe in this idea of serious use. So agents, it's really easy to make a demo on Twitter. It's like, oh, this agent is magical. It's like really cool. But when I'm using it every day, like it's actually really hard to get to an agent that I want to use every day because it has to be reliable and trustworthy, and it's very easy to lose my trust. So serious use, what that means is we want to get to things that we can use every day. And the nice thing about code is that code is the primary blocker for us. So that's the primary activity we do, and having coding agents like really helps accelerate us and really helps us understand, like, are we seriously making progress, like working on the right problems? And that's why I say, like, we don't work on reasoning in the abstract, we work on reasoning in a very pragmatic way. The second reason for code is like code seems to really help with the model's reasoning. And
yes?
Yes, I think this is known now.
Yeah. It is known, but I don't know of a conclusive paper to point people to.
That's true. There is no conclusive paper.
So can you guys publish a paper?
I don't really want to do that. But, it's intuitively interesting. I think it's actually pretty hard to prove that code makes reasoning better because reasoning benchmarks don't really exist. This is primarily, I think, why no one has published this paper. It's hard to be like, oh, okay, it's like improving on X benchmark because it doesn't make it better at question answering. It makes it better at kind of like step-by-step getting to the right answer. So, and I'm not sure if training on code makes it better at like math or anything. So I'm not sure which benchmark I would use. But for code, like a way to think about it is code is the most explicit example of reasoning on the internet. Like on the internet, we're not saying, okay, first I thought this, and then I thought this, and then my conclusion was this. Instead, what we have is Reddit posts. And so that's kind of the like general quality of text on the internet when we look at our training data.
The best data set for reasoning and planning might be cooking, like recipes.
So I think recipes are actually terrible.
Oh,
And it's because what I wanted was to start from a goal and to kind of first principles break down how would I accomplish this goal.
Right.
But a recipe just gives you the answer.
yeah.
So that's not what I wanted. I wanted to reason through, okay, well, if I'm doing this, then I need to consider these things. It was really hard to do that with food.
Yeah. Archive, like, there's a lot of, like, I really read, when I read a paper, there's always, like, introduction with, like, every single, the obligatory, like, Vaswani et al. Mentioned, right? And then there's, like, every other solution is terrible, here's ours. And, like, and here's how we solved it, and here's the results, right? Like, that's a pretty good data set, that's
Yeah.
exponentially increasing.
We're still experimenting with the archive data set, and also like PhD theses. We haven't run an experiment, we haven't run ablations on the PhD theses yet. But our current experiments seem to show that books are the primary, basically, we have a really nice hyperparameter optimizer that automatically figures out like what data mix is best. And
this is carbs.
this is carbs, yeah.
Oh,
Which you can
it
see.
works on data mix?
Oh, yeah, we can have it optimize all sorts of hyperparameters, including data mix.
Yeah, sorry, you were explaining carbs.
Oh, yeah, carbs is a hyperparameter optimizer that is cost aware. You can look at it on our website. And so what it does is it starts with smaller models, and it'll run some experiments with smaller models, and then it finds the Pareto front of cost and performance, which means it'll basically find the highest performing model at each model size, or at each kind of compute. It's not always size. It's like how much data you use, how much given a certain amount of compute, what's the best performing model, and what are the hyperparameters for that? And it does local search, and so what happens is it generally never has to like try big, expensive, low-performing models. It'll always try big, expensive, high-performing models. So what Carbs found is that it upweighted books data by like 8x, 6x. Versus internet data.
Oh, wow.
Yeah.
That's great.
And it actually downweighted Wikipedia data, so we're kind of confused about this right now.
Interesting. But still, the takeaway is that you've automated your jobs as ML researchers.
That's that's kind of like in the whole line of thinking around agents, like our purpose is to try to make ourselves as high leverage as possible.
Yeah. I'm getting a time check. Okay. Yeah, we have people have been submitting stuff in Slido, and I'm sure Kanjun is here to answer more questions after that. I think one of the more
most interesting question?
I know. I'm having to sort of scroll through and just kind of pick one. I'll pick the first, which is what's the best way of making AI agents aware of business data and workflows, right? So you're doing general reasoning. I think people want sort of in context within their business environments, and like, are you working on that?
Yeah, so we, as part of Serious Use, we have a lot of use cases internally, and also with like a few other folks that are business workflows. So we have a lot around recruiting. For example, synthesizing candidate feedback to give to candidates. People go through our recruiting process, they'll ask for feedback, and we want to give them thoughtful feedback. It's actually a really tricky problem, because people get really angry if we give them generic feedback, and they also get angry if we give them incorrect feedback.
Yeah.
And so, like, how do we turn the interviewer's feedback into an email that is actually, like, thoughtful and synthesizes the core themes? It's actually quite tricky. It requires a lot of context, requires reasoning through the situation, the job description, everything like that. That's an example of a business workflow. One of the things that we're working on, and kind of the purpose of, like, I say we build agents, but the reality is we're kind of like trying to build an operating system to enable agents, to enable other people to build agents. And I think some of those other people are going to be founders, but a lot of them are going to be business users. One of the things we're experimenting with is how do we enable business users to break down their problem, their workflow, in a way that can easily make sense to the model. And this is actually very tricky. Because as we're breaking down, a lot of our internal business use cases, it's not very intuitive what the model is going to work well with. And so improving underlying reasoning is going to help with that, and then better tooling will help with that.
Excellent. I think we're getting the timeout signal, but thanks so much, Kanjun.
How about a big hand for
Thank you,
Kanjun and
Shawn.
Shawn? Great job.
Also, I want to give a plug for Shawn. So Shawn has an amazing podcast called Latent.Space. If you're interested in AI, he interviews a lot of founders and researchers and asks really thoughtful questions, and I listen to it. So
Thank you so much.
Great job. Great job.
And Kanjun's hiring.